of Construction Materials. He obtained a Bachelor of Science degree in 2007 and graduated with a PhD from the Department of Civil Engineering at the University of Nottingham. He currently holds the role of Global Technology Development Manager for Shell Specialties and is responsible for the commercialization of new technologies and materials. His paper is entitled The Impact of Asphalt Aggregate on the Bitumen Technology.
Yeah, I think there's a small error there, but the title's right on the slide anyway, so.
Okay.
No problem. Nice to see a full house, especially after all that concrete talk. Yeah, I'm going to talk about the role of bitumen in recycling. So I'm going to start off by describing a little bit about the chemical composition of bitumen, how that changes over age, and I guess I'm going to give a sort of view of the main sort of state of the arts in terms of how do we restore that bitumen property when we reuse RAP in asphalt pavements. And then I'm going to switch track slightly to talk about the role that bitumen plays in the recycling of tyres at the end of their life and the use of ground tyre rubber in bitumen. I would say before I start, there's not a lot in here. We're very much down the kind of microscope of bitumen chemistry and its changes and restorative techniques. I'm going to say a little bit about asphalt mix design because at the end of the day, all roads will lead back to proper volumetric design and a suite of tests which give you information on the performance of the asphalt. And I say that for a good reason. It's very, very interesting to talk about bitumen chemistry and the rheology and properties of bitumen. Nothing can overcome the need for good mixture volumetrics. And I can say, coming from the UK and our experience of implementing hard bitumen in the UK and the story of how the UK eventually found EME, I see quite a lot of parallels in the RAP story. And so somebody wiser than me once said at a conference, they asked a question at the end, so if it's very difficult to use RAP with hard binder, why do we pay a premium for 1020? Which I thought was quite a good question. And I think that we have to learn to respect mixture volumetrics, particularly when we're using hard binders. And whether that hard binder is a fresh binder or whether that comes from RAP, I think the basic principles there are the same. So I thought I'd say that before I start, because I'm not going to mention mix design very often in this, so it's not just about the binder. Okay. So bitumen is quite a complicated material. It's obviously produced as during the refining of crude oil. There are hundreds of thousands of different compounds that make up the chemistry of bitumen, and this means it's quite difficult to describe bitumen chemically. And so typically people will use a rheological term to describe bitumen, so penetration test or softening point, or increasingly we will use more fundamental nomenclature like G star, or we'll take some more fundamental rheological properties. And so we don't tend to describe bitumen in a chemical way. We tend to describe, even aging, we describe as a change in rheology from one type of rheology to another. The bottom line is, as the bitumen ages, it becomes progressively more viscous in the pavement. And as it ages, there are certain species within the bitumen, as I'm going to show on the next slide, which actually increase in polarity, so they pick up the more polar compounds through aging. And so the challenge, I guess, when it comes to RAP, if we look at it chemically, is how do we put this aged material, this material that's naturally got older and has more insolubles over time, how do we put that back into the next surfacing? So this slide is from some of our recent research, and it throws up quite a few questions. The first thing that should be quite striking here is that sorry, for those that are not perhaps so au fait with bitumen chemistry, at the first cut, bitumen chemistry tends to be described by solubility. And so the insoluble part of the bitumen we would refer to as an asphaltene, and the soluble part of the bitumen we would describe as a maltene. So asphaltenes in the insoluble part, they don't melt. They're not, they're kind of pseudo-solids, I would describe them. And what you can see as bitumen ages, and there are some very long-term laboratory aging tests is that the oxygen, if we look at the oxygen, ends up in the asphaltene. So there's a kind of a partitioning effect here. And so what we end up with are two things. We end up with more insolubles in the bitumen, and we end up with larger, generally speaking, larger insolubles. And you can see the kind of the level that's reached here. I can't see on here. It's 18 days. So we've actually used a standard piece of testing equipment here for 18 days in a PAV. So anyone who's tested bitumen can imagine what the 18-day-old PAV-aged bitumen looks like. It's very, very hard. We can manage to squeeze about 2% of oxygen into that asphaltene fraction. Just as a reference point, and we are at the moment currently working on some RAP that's taken from a UK road, in naturally aged RAP, where we've recovered the asphaltenes after 10 and 15 years, we can find more than double the amount of oxygen in that asphaltene fraction. So that does raise some questions about the ability of the relatively thick film aging tests we use today to approximate field aging of the binder. And so basically what we've got is we've got a material, hydrocarbon-based material is picking up oxygen and other elements as it ages in its life. It's getting more progressively viscous. Rather unsurprisingly, number one tactic here is to put something of a lower viscosity with the bitumen. And we'll have seen over the last years a growth in the demand for softer grades of bitumen as the RAP contents and recycling have increased. If you increase your quantity of binder coming from the RAP, then not surprisingly you need to add a binder which is significantly softer in order to restore that back to the penetration or the target viscosity of the mixture, which is fine. The current trends in refining, I would say, or I could even actually remove the word current and trends, but refining tends to not like to leave things soft in the residues. It tends to work in the other direction, and so refinery is driven by not having too much soft stuff left in the bottom. And one thing here is that restoring rheology doesn't restore chemistry, so it doesn't restore aging. You mix some soft component with some hard bitumen, you will restore the rheology, and this is sort of harking back to my opening remarks about the need for good mixture design, particularly when it comes to aging. And what happens after the blend has been aged in the asphalt mixture itself. And so restoring rheology doesn't restore chemistry. So these more polar asphaltenes, they're still there. They might have been diluted, there may be less of them because you've added something else, but you're not fundamentally restoring or able to reverse the chemistry. One curious thing that we've seen from our own work here is that and it's actually to be very accurate here, this is true of some of the blends that are not RAP related. However, our observation is that when you blend bitumen and RAP together, it isn't a perfect, it doesn't perfectly follow the blending rule of normal bitumen. Now, I would say that this is in the binder itself. This is not in an asphalt mixture. But we're able to observe two things. One is a deviation from the normal log blending rule. The second thing that we've observed from our own research is a small but measurable steric hardening when you mix the more polar aged binder with the fresh binder. Again, to balance that, even when you mix two bitumens together, there is a small amount of measurable steric hardening, just because it's a blend of two things and it takes a little bit of time to sort itself out. Just to give a magnitude, we're only really talking about 5% maybe increase in stiffness over time. And so this is not a big effect, and I'm not sure as this can be even measured in an asphalt mixture, but under laboratory control conditions, you can measure a small amount of hardening when you mix the two. Now that may lead you to the conclusion that the blend that should be used should be slightly softer than the one that we have in our minds today to take account for this. What we have here is a picture of some solubility spheres. So these are it's not a particularly new concept, I would say, that the solubility. The difference here is that we've split the solubility into different chemical species of the bitumen. But we are seeing increasingly a kind of, as well as rheological matching, if we try to rematch the chemistry of the bitumen, you need to be more sophisticated. And so these spheres allow you to, if you measure solubility parameters of different materials, you can actually map out an overlap to show how miscible or how closely in terms of solubility parameters those two materials sit together. The powerful part of that is as you age these two, you will see the spheres start to move apart. And so actually, as you age the soft component with the bitumen or the softer bitumen, whatever you've used to generate these spheres, you can actually see what happens over time as the solubility parameters between the two materials changes. And we've seen our former colleagues in Japan, in Showa, we've seen there is some SARA matching, I would describe this. So SARA is saturates, aromatics, resins and asphaltenes. There are some people that are attempting to do SARA matching, so they will say, I will measure the chemical solubility of your binder, and then I will take refinery streams and I will blend you a bitumen so that the net effect of that rheological reconstitution of the binder is you end up with something with a SARA analysis similar to bitumen. Of course, the key to that is to have something that's relatively low in asphaltenes, and you have something that's soft so that you can rejuvenate the binder. One thing I would say here is that not all insolubles are asphaltenes, and conversely, not all solubles are maltenes. And so you will often see maltene restoration. You know, as an extreme example, of vegetable oil is not a maltene fraction. Okay, it might be when you add it to the bitumen and then you make a SARA analysis, it will come out in the part of the binder that is soluble, but that doesn't mean that it's a maltene by definition. And you could extend that to anything soluble. You could actually claim to be a maltene. For me, a maltene is the soluble fraction from the refinery bitumen. Okay. Wrap and warm mix asphalt brings with it some extra complexities. Obviously, to reintroduce the wrap into the mixture, a lot of plants still rely on superheating of aggregate. Okay, of course, if you've got a parallel drum or you have a more sophisticated plant, adding the wrap in high quantities doesn't need you to elevate temperatures. So there is a conflict or a potential issue to overcome when using high quantities of wrap and warm mix technologies together. There are a number of ways in which that can be achieved. From a bitumen perspective, there are additives that can be put into the bitumen to lower the viscosity or make the wrap easier to work when it's in the bitumen. I think it's fair to say that a lot of warm mix technologies are used, in fact, to increase wrap rather than to lower temperatures. I think that that's a general observation, but I think it's fair to say they're used more as compaction aids. Luckily, they have the brand and the tag of warm mix additive. However, they are useful for increasing workability when using higher quantities of wrap. You can have special manufacturing techniques. I was fortunate enough to speak at the PPRS in Paris, where I talked a little bit more about this. You can buy a kind of a maltene fraction or a special flux that you can mix with the wrap, and so at very high quantities reintroduce the fresh binder as a foamed component to make a warm mix. And by warm I mean compactable at maybe 120 degrees. You can make a high wrap warm mix by a combination of foam bitumen and fluxes. Finally, on the wrap side, on the recycling of asphalt side, there is going to be quite a lot of wrap turning up with polymer in it. Now, that isn't a new story. We're not generally, as an industry, that good at segregating wrap. And what we're going to find is that the surfaces at the end of their life are going to contain, you know, a fair proportion of a very high quality, expensive component. which may have a use in the subsequent layers of the road. And so we will see more and more, as polymer modification of surface layers becomes more commonplace, we will see more and more wrap being generated that has polymer in it. At the moment, I would say that largely gets diluted and is lost into the layers of the road in which the wrap is used. We don't really try to take a benefit from the polymer that's already there. I know there are pockets of good practice and good examples there, but as a general rule, wrap tends to be treated as a kind of a standardized sort of material. And we tend to look at the penetration of the bitumen and see how much can go back into the... And so understanding the potential to reuse the polymer and wrap, I think, is going to be a challenge for the future. I'm going to switch now away from wrap to talk about crumb rubber, another really important part of the recycling story. This is a picture from our friends in Germany, our colleagues there, showing the cleanliness of the truck when using crumb rubber. Bitumen and crumb rubber are not naturally compatible. Anyone who's tried to blend the two together and observed a tin of it will soon find out that they're not the greatest of bedfellows. It's okay if you're in an on-site mixing where you're just blending in the rubber and then using it before it has a chance to settle, but largely speaking, the crumb rubber will settle from the bitumen. And so from a binder technology point of view, it's important to use some sort of compatibilizers which allows the crumb rubber to stay in solution more freely, more readily than it does if you just blend simple rubber and bitumen, maybe some oil to soften the mixture. The second part of the bitumen technology story for crumb rubber is allowing the use of viscosity modifiers to reduce the temperatures for laying and compaction. Crumb rubber makes the binder incredibly viscous. This will sometimes mean that people elevate temperatures. With the temperatures comes energy use, but also with the temperature comes increased emissions, and it also makes the material slightly more likely to separate at high temperatures actually. And so using a viscosity modifier to lower the binder viscosity combined with some compatibilizers which help keep the rubber in solution. There's two ways in which bitumen technology can help with the recycling of rubber. I'm going to conclude on some emission-related work that we've been carrying out in China. And so last year, Shell filed a patent on an additive which can reduce the emissions and odour from crumb rubber modified mixtures. So this is just some pictures from both the mixing trials in the lab and the instrumented trials in the field. I think I see the odour and emissions as being quite a barrier to the increased use of ground tyre rubber in bitumen. Anyone, again, who's been at a paver using recycled tyres in bitumen will know what that experience is like. And so we have found a way to additivate the bitumen, which actually will mean that a lot more of the emissions from the rubber and the odour from the rubber remain locked inside of the bitumen. So just to summarise, wrap's an essential part of the asphalt story, genuinely recyclable, reusable in asphalt mixtures. Understanding the fundamentals of bitumen wrap is really crucial. If we're going to maximise the use of wrap and the benefits from wrap, we need to understand what happens when bitumen ages and what happens to that material in the subsequent cycles. And there are a lot of bitumen technologies that have a role to play in increasing the use of wrap, and they include lower temperature binders with viscosity modifiers, soft bitumens, special bitumen-like fluxes. And again, when using ground tyres and crumb rubber in asphalt, bitumen with special additives to improve the compatibility and improve the workability, and more recently improve the emissions and odour characteristics of such mixes have been developed. Thank you.